and welcome back to Algebra 1. Our goal for today is to continue working with our factoring polynomial expressions completely, and sometimes we have a special case where we can't do any factoring called prime. So at this point, we should understand there's 4 different types of scenarios that can happen. So option 1 is I pull out that GCF factor, and I break my problem into 2 what are called factors. Right? So this example has a factor here of 3 and a factor of x squared plus 4x minus 10. That is not prime. I took the original problem and I was able to break it apart. By definition, that means I factored it, right? The breaking apart process is factoring. So that would not get a prime description. I just couldn't factor it further with the chart, so be careful. So as long as I take that original and I do some type of breaking up into things that multiply to get the original, I cannot associate it with the word prime, so be careful. All right, scenario number 2 says there was no GCF way of breaking the problem up, but I could go to the chart to break it apart. So again, in this case, we have 2 factors. This factor of x minus 6 and this factor of x minus 1. And we ended up with 2 things that multiply to get us back to that original problem. All right, scenario number 3, I broke the problem apart with a GCF and a leftover. As soon as I got here, I can no longer say prime, but I still have to check to see if I can factor further. In this case, we could. So we could take those 2 factors and break them up even further into 3 factors. We end up with a factor of 2, a factor of x plus 4, and a factor of x plus 1. In this case, we end up with 3 factors. And then finally, I can't break out, there's no GCF factor I can pull out, and I can't break it up to go to my chart and factor further. So in that case, we have no way of breaking apart the original problem, and that would be considered a prime polynomial. So last 3 additional examples in our notebook for today. We want to see if we can factor the quadratic trinomial x squared plus 4x plus 3. Now, keep in mind, as long as we can do any type of breaking it apart into things that multiply to get us back there, we can't write the word prime. So in this case, x squared, 4x, and 3 don't have a common factor. So right now we're thinking, well, maybe it is prime because I couldn't break it apart by GCF. However, this has a degree of 2 or higher, which means I have to do the guess and check to see if I could do any factoring with my chart. So I go there next, right? We would need factors of 3 that would end up giving us that middle term of 4. 1 times 3 here is a magic combo that does work. So I'm able to make this a quadrinomial and use my chart. So this one's not going to be prime. We're going to get factors from our chart. So we have an x squared, a 1x, a 3x, and then plus 3. We can take that to our chart, x squared, x, 3x, and 3. We can go row by row, column by column, and pull out our GCF. So top row, x squared and x both share an x, 3x and 3 both share a 3. So we do have a factor here. One of the factors is an x plus 3. Definitely not prime. All right, same thing with our columns here. X squared and 3x both share a common factor of x, and x and 3 both have a common factor of 1. And so we end up in this case with 2 factors. One is an x plus 3, and the other is an x plus 1. Definitely not prime because we were able to break it apart into things that can multiply back up to that original. All right, number 2. We want to try to factor completely our binomial here that is a quadratic binomial of 9y squared minus 14. All right, 9 and negative 14 actually don't have any common factors. They don't both have a y, so we can't break it apart by GCF. But we're given a binomial here, so our first step is to get it to a trinomial in standard form with that missing term as a placeholder. So we have 9y squared plus 0y minus 14. We haven't done any factoring yet. We've just gotten the problem in a format that we can now run our guess and check to see if we can factor further. So right now we're still thinking maybe this is prime because we haven't broken apart into anything that multiplies to the original. So now we go to our guess and check. So 9 is our leading coefficient. We have to multiply that with our constant term of negative 14. That's going to give us a negative 126. We need that number here in the middle to be a 0 when we add up our digits. So remember, when we want a 0, that means we're going to square root this number. Now, in this case, 126 is not what's called a perfect square, which means when we square root 126, we end up with a number like 11 point, right? And we get decimals like 2, 2, 4, 4, right? And it looks like this is irrational, right? And it goes on forever, which means there's not going to be a magic combination here that works perfectly that gets us back to 0, right? Like 11 and 11, right? That's slightly where we have perfect numbers without decimals or fractions. So we can't go to our chart here either. So now that we know we can't use our chart and there's nothing to pull out, then we can identify that this was a prime polynomial. All right, number 3. We have 4a to the second plus 24a plus 32. We want to see if there's any way we could factor. Can we factor by GCF? And since this has a degree or 2 or higher, can we also go further with our chart? All right, when I look at these terms, 4, 24, and 32, they do have a common factor of 4. So we can definitely factor out 4. And right now, since I'm taking the problem and I'm breaking it apart into 2 things that multiply the original, prime is out, right? Because we were able to do some factoring. Our leftover here then would become an a squared when we divide 4a squared by 4 plus a 6a, right? We're going to take that 24a divided by 4, and then we take our 32 and divide it by 4, and we'd end up with plus a. All right, so prime is out, but we still have to check to see if we can factor further because this still has a degree of 2 or higher. So now we have to go to our guess and check and see if we can go further. All right, we need factors of a that maybe give us a 6. All right, well, 4 and 2 here, that's a magic combo that works for us. So we can go further. This is going to be a 4 times, this is going to become a squared plus 4a plus 2a plus a. All right, let's go to our chart here. A squared, 4a, 2a, and a. All right, since this is kind of close to the top of mine, I'll go down here for the columns instead. Normally we would go up. All right, but it's going to give us the same thing. A squared and 4a both share an a. 2a and 8 both share in 2. All right, so we have a factor of 4. Don't forget that guy. We now have an additional factor of a plus 2. All right, so 2 factors so far. All right, a squared and 2a both share an a. 4a and 8 both share a 4. So we also have a factor here of a plus 4. And so in this case, we could factor it to 3 separate factors. Definitely not prime. All right, I hope that helps you attack your work for today. See you guys later.